This is the video lesson for balanced versus unbalanced forces. In this video, we're going to learn about the difference between balanced and unbalanced forces and what they mean for an object's motion. All right, so let's talk about unbalanced forces. So in this diagram, we have a box or a crate on the floor, and this stick figure person is pushing it to the right. So we have gravity pushing downward. We almost always have gravity. And so we have this arrow, this gravity, the arrow, which represents gravity, pushing down. And then we have the arrow at the bottom representing the normal force pushing up. And notice that these two arrows are the same length, which means that they are exerting the same amount of force. So gravity and the normal force are usually the same, meaning that they're balanced, meaning that they're offsetting each other completely. If the normal force and gravity were different, then if gravity were stronger, the box would be pushing through the floor. And if the normal force were greater, the box would be lifted up off the ground into the air. So the applied force, which is, remember, just a catch-all name for a force, the person is pushing the box to the right with the applied force. So this arrow, notice, is longer than the arrow with friction. So therefore, the box is moving to the right. It's offsetting the friction, and it's actually accelerating to the right, because unbalanced forces, if you remember Newton's first law, an object in motion stays in motion, and an object in rest stays at rest unless acted upon by an unbalanced force, a net unbalanced force. So here's our net unbalanced force pushing the box to the right, so the box would be accelerating. So here we have balanced forces now. So you can see all four arrows. The gravitational arrow is the same length as the arrow representing the normal force. So those arrows are the same, so they're balanced. And the friction force is balanced by the applied force. So if the box was in motion before, which we know it was, now the box is moving at a constant speed rather than accelerating. If the box was at rest, it would be maintaining its rest state because the forces are balanced. Here we have a velocity time graph representing the motion that we just saw. So while we had unbalanced forces, so unbalanced forces creates an acceleration. So while the forces were unbalanced, we had an acceleration. So that's when we have a positive slope on our velocity time graph. So positive slope. And then here is where we have balanced forces. So we have a constant velocity. So balanced forces means we have a constant velocity or the object is at rest. So since the object was already in motion, once we apply balanced forces, we end up with an object moving at a constant speed. All right, so here we have another example of unbalanced forces. So we have a skydiver falling, jumped out of a plane maybe, and here we have a gravitational force pulling the skydiver down towards the ground, and you'll notice that the gravitational force is actually longer, which means it has greater force than the air resistance force, which is pushing against the skydiver. So the skydiver is falling faster than the air resistance is keeping up with them. So we have an unbalanced force pointing downward, so the skydiver is accelerating towards the ground. Here, though, we have balanced forces. So the gravity is now offset by the air resistance. So you'll notice that the arrows are the same length. So the gravitational arrow, the force of gravity, is the same as the force of air resistance. So this skydiver is now in terminal velocity. So what we call terminal velocity, meaning that they can't go any faster. Gravity cannot pull them towards the ground any faster than they're already moving, because air resistance and the gravitational force are balanced for them. So they're moving at a constant speed, so they have balanced gravity and air resistance. All right, here's a velocity time graph for this motion. So here we have an acceleration downward. So we have motion downward, so it's accelerating in the negative direction. So this is the portion where we have unbalanced forces. So here we have balanced forces. So this is where the skydiver reached terminal velocity. So this is terminal velocity. Right here, the skydiver now has all of a sudden sharply increased their speed, or they've slowed down rather. They have a positive acceleration. So they have unbalanced forces again. Unbalanced forces. So they have a positive acceleration, so they slowed down, but they're still falling. They still have a negative velocity. So this is where they pulled their chute. Pulled their parachute. And here, where they have a constant velocity, so they have balanced forces. So they're moving at a constant speed. So this is where they're floating to the ground under their parachute. Floating to ground under the parachute. So you can see the areas where they're accelerating, they have unbalanced forces. And then the areas where they are moving at a constant speed, they have balanced forces. So unbalanced forces, you're accelerating. Balanced forces, you're either moving at a constant speed or you're at rest.